everyone, I'm Xiaoxueren from Zhejiang University. I'm glad to be here to introduce my work. Demystify official API usage directives with crowdsourced API misuse scenarios, erroneous code examples, and patches. It is cooperated with Jiamo Sun, Zhen Changxing, Xinxia, and Zhenling Sun. So let's begin the talk. As we know that Stack Overflow is an open community to help users to get answers to their coding questions. Developers often look for answers from Stack Overflow. In addition, developers also read API usage directives from Android developer official website. However, what is the relation between Stack Overflow and Android documentation? In this case, we would like to link Android documentation with Stack Overflow. From previous study, many questions on Stack Overflow are caused by developers' ignorance or misunderstanding of API usage directives in official documentation. Let's look at the example from Stack Overflow. Here is a question from Stack Overflow. This is the question details. From the answer, we can find the answer that using documentation as the answer body. The documentation refers to the code in the question body, from which we can summarize that the correct answer should be using intent flag activity new document instead of intent flag activity new task. The correct answer also appears in another answer body, which contains some code, just like this. It can be seen that the documentation often uses relatively long sentences to explain the usage of APIs, which can appear in the answer of Stack Overflow, while some code snippets of answers can deal with the problems more clearly. In this case, we motivate to extract error scenarios from Stack Overflow to enrich API usage directives. We would like to generate demystification report to enrich API usage directives. So, here's our framework. The first step is preparing dataset. We extract the API inventory and API usage directives from Java official documentation, and we extract the discussion threads from Stack Overflow. The so-called discussion threads include question, answer, and comments, as well as their votes. Then the second step is finding API misuse scenarios. We use API partial name to filter out discussion threads. Thus, for each API usage directive sentence, we can get its consumed API and a list of candidate discussion threads. In order to get more relevant scenarios, we score all candidate discussion threads using sentence matching approach from both macro and micro levels. From the macro level, we treat one discussion thread as a whole test, and we use BM25 to compute the similarity between API usage directive and its candidate discussion threads. The normalized similarity is treated as a macro similarity. From the micro level, we split each candidate discussion threads into sentences. For each sentence, we use word embedding method to compute sentence similarity between API usage directives and sentences of candidate discussion threads. We select the highest sentence score as a micro similarity. Then we use a weight of 0.5 to balance macro similarity and micro similarity. Thus, we can get API misuse scenarios. Once obtained API misuse scenarios, we can make further analysis. For the selected API misuse scenarios, on one hand, we can select the high-quality code examples in questions with regard to length of code and code relevance and so on. On the other hand, we use some heuristics to filter in recognized answer, and also select the high-quality code examples from recognized answer. If there is no coding answers, we consider the whole answer test. After selecting codes, we should match code from questions with code from answers using method of bag of tokens. Thus, we can get pairs of erroneous code examples and patches. So that with a combination of API misuse scenarios and erroneous code example and patch pairs, we can generate our demystification report. Note that for our demystification report, there can be just error scenarios without pairs of erroneous code example and patch, which is because in lack of qualified answers. For better understanding, we also define the related API and confusing API in our report. Let's show an example to explain it. Here is an example of our demystification report. For the consumed API and the consumed usage directive sentence, we find the two misuse scenarios from Stack Overflow. In the first scenario, the patch is in natural languages, and it doesn't have related API and confusing API. The confusing API refers to the API that only appear in misuse erroneous code apart from consumed API. And the related API refers to other APIs that appear in error news code or patch, apart from confirmed API and the confusing API. The second scenario have both related API and confusing APIs. To assist developers in understanding the demystification report, we detect and highlight the code differences between the error news code example and the corresponding code patch, just like the purple patch. After knowing our framework, let's show some experiments and results. We evaluate the quality of each step of our framework to make sure our approach can be the most appropriate one. We adopt a statistical sampling method to examine the minimum number of API usage directives for each type of the extracted information in the demystification report. We evaluation metrics include accuracy and MRR, and the two authors independently evaluated the accuracy of the sample data instance. We compute the coherence kappa to evaluate the inter-rater agreement. For time limitation, please refer to our paper for more experimental setup details. To find the relevant API misuse scenarios for a given API usage directive, our approach combines the macro-level relevance by BM25 and the micro-level relevance by word embedding. We consider using only BM25 and word embedding as baseline. Furthermore, we use Google Search and the search engine of the Stack Overflow website as the other two baselines, which simulate the situation when developers search API misuse scenarios for an API usage directive on the web. It can be seen that Stack Overflow search engine performs the worst in finding API misuse scenarios because it uses very primitive keyword-based search. The two annotators mostly agree on the irrelevance of the Stack Overflow search results. And the Google search and word embedding have the similar performance in ranking. The word embedding has a better accuracy due to its more strict selection threshold, and the high MRR of these two baselines suggests that the first return results are very likely to be the relevant API misuse scenarios. In contrast, the BM25 and our method perform much better, and the two annotators have almost a perfect agreement on the relevance of API misuse scenarios. This suggests that the macro level ranking by BM25 is an effective method to find API misuse scenarios. For the quality of extracting error news code examples and patches, our approach finds the pairs of error news code examples and patches by bag of tokens matching. Here we use bag of words as a baseline. This table shows the performance of the two methods for ranking candidate pairs error news code examples and patch. The kappa metrics are larger than 0.7 for both methods, which indicates that substantial agreement between the two annotators regarding the relevance candidate pairs of error news code examples and patches. The MRR and accuracy of the two methods are very close, and our methods is slightly better. The close MRR indicates that bag of tokens matching and bag of words matching do not make a big difference. However, when looking into accuracy, we find that bag of tokens matching can be better. For the quality of identifying related APIs and confusing APIs, our method can almost perfectly identify related APIs. The accuracy of identifying confusing APIs is also acceptable, but it is more challenging, partially due to the code informality on Stack Overflow, and partially because the vague definition of confusing. After the quality evaluation, we also conduct a user study to evaluate the usefulness of our demystification report. We prepare 8 tasks for 14 developers to answer, based on the development experiments of these developers. We divide them into 2 groups, Group 1 and Group 2. Each group has 7 developers. Group 1 is control group that are given only confirmed API usage directives, while Group 2 is an experimental group that are given our demystification report. We evaluate the participants' perform based on their task completion time and answer correctness. The table shows the average answer correctness and task completion time. The result shows that the answer correctness of experimental group is better than the control group, and the experimental group can complete the task faster. In conclusion, participants suggest that the Demystification report can help them in two aspects. One is summarize meaningful information to find a solution, and the other is enhance their confidence on the answer. Although they have to spend time on reading the report, nobody complained about this effort. It seems that they consider the help offered by the report worth of the time spent. That's all my talk. If you have any questions, please contact me. Thank you.